Now let us study about Norton's theorem. Norton's theorem also one of the theorem to simplify the electrical circuits as like Thevenin's circuit. So we have seen in Thevenin's theorem the total circuit is simplified into a voltage source with series resistance, that is Thevenin's voltage source and Thevenin's resistance. Now in Norton's theorem also we have to convert and simplify total electrical circuit into two elements. One is current source, that is Norton current source, and another one is resistance, that is Norton's resistance. So this finally we get these two elements, one is current source and resistance. This current source and resistance should be connected parallel at last, and first we can calculate the currents and resistance at load conditions. Okay, how can we calculate this current source from network? So we'll see. So this to calculate this short circuit Norton's current source, what is we need to do? Load terminal, suppose this is network. In this network, load terminals A and B, first short the load terminals and calculate the short circuit current through this load terminals, then that is called Norton's current source. Okay, then after that to calculate the Norton's resistance is Ri or Rn. So for this, open this load terminals and visualize from the node load terminals and calculate the equivalent Norton's resistance. This is similar to Thevenin's resistance. Okay, so like this you calculate, you have to find out the Norton's current source and Norton's resistance. Okay, Norton's current source for voltage across terminals VAB equal to ISC into RI. Okay, this is. So what is the definition of Norton's current source? Any two terminals active network containing voltage sources and resistance when viewed from its output terminals is equivalent to constant current source. Constant current source. 1 second. Constant current source and a parallel resistance. The constant current is equal to the current which would flow in a short circuit placed across the terminals, and parallel resistance is the resistance of the network when viewed from these open circuited terminals after the all voltage and current sources have been removed and replaced by their internal resistances. So while calculating the Norton's resistance, what you need to do, whenever any voltage source is there, then voltage source should be replaced with the internal resistance, and if current source is there, current source should be opened with infinite resistance. So like this you need to calculate Norton's current source and Norton's resistance. The voltage between two points in a network is equal to ISC. ISC means short circuit current, the another name is Norton's current. RI, where ISC is the short circuit current between 2 points and RI is the resistance of the network as viewed from these points, with all voltage sources being replaced by internal resistances and current sources replaced by open circuit. Okay, always remember that in Norton's calculations or in Thevenin's calculations, you need to voltage sources should be replaced with the internal resistances, current sources replaced with open circuit. Okay, nice. Norton's theorem steps. How can we do the calculations in Norton by using Norton's theorem? First step is remove the resistance across the two given terminals and put short circuit across them. Means, suppose you want to calculate the current through this one, you want to apply Norton's theorem between A and B, then remove whatever resistance is there across the terminals. You have to remove that and put short circuit. Okay, short circuit across them and compute the short circuit current. Compute means calculate. And step 3, remove all voltage sources but retain their internal resistance if any. Similarly, remove all current sources and replace them by open circuits, that is by infinite resistance. This is very important bits for competitive exams. So voltage sources should be removed with internal resistance. Current sources should be removed with infinite resistance. Okay. And step 4 is find the resistance of the network looked into from the given terminals, from in this perspective. After opening the A and B for calculating the Norton's resistance, you need to see the effective resistance across the terminals A and B. So this is, it is exactly as same as RTH. RTH means Norton thermal Thevenin's resistance. Okay, step 5. Step 4 is over. Step 5 is current source joined in parallel across RI between two terminals gives Norton's equivalent circuit. Okay, you are seeing this one. So like this, you need to apply Norton's theorems for any electrical networks to simplify and get the results. Okay, we'll see the one example on Norton's theorem. Okay, this is an example here. This is a circuit where 100 volts resistor, 100 volts source is given, voltage source, and internal resistance is 0, and 10 ohms resistor and 10 ohms is connected in parallel to this combination, and 15 ohms is series to the load, and this is the load terminals, A and B load terms. Now this circuit we need to convert into Norton's equivalent circuit. Norton's equivalent circuit means what is Norton's equivalent circuit? 1 volt current source, that is Norton's current source IN, should be parallel to the one resistance, that is Norton's resistance, then we can say RI also. So now we need to do, first we need to calculate IN. IN means Norton's current, which is equivalent to short circuit current between load terminals first. So let us see the solution of it first. Now okay, in first step, short A and B load terminals, this is short circuit current, where this is called Norton's current also. Now after shorting, then calculate the total resistance. Okay, total resistance is 15 ohm. This 15 ohm and 10 ohm became parallel. 10 and 15 become parallel. Parallel combination of resistance is nothing but 15 into 10 by 15 plus 10, means two resistors if in parallel, then what is the formula? R1 R2 divide by R1 plus R2, like this. Okay, and then this parallel combination of resistors in series with 10 ohms resistor. So total equivalent resistance, total resistance is 16 ohms is coming after solving this one. This 16 ohms, through this 16 ohms, 100 volts voltage source is there. Then total, what is total current? 6.25 amp. Then total current is 6.2. Total current 6.25 amps is flowing here. Okay, so this 6.25 amps will be divided into two parts. One is this path and another one this path. So this 15 amps 15 ohms path, whatever current flowing through this 15 ohms path, that is same as short circuit current between A and B. So that is another name is Norton's current. So what is the current flowing from A and B? A and B is nothing but here, this is a total current into opposite resistor. Opposite resistor is how much? 10 ohms. Opposite resistor 10 ohm, and divide by total resistance. Total resistance is 25 ohms. 25 ohms means like total resistance is, here opposite resistance is 10 ohm, total resistance is 10 plus 15, 25. So by calculating this, here I is nothing but, here I is 6.25 amps already calculated here. So now the current flowing through 15 ohms, the current flowing through this path is 2.5 amps, which is equivalent to short circuit current, because same current will pass through this one. Okay, now this is not short circuit current or Norton's current, and one element is calculated. And another, coming to Norton's resistance. Norton's resistance is nothing but, by opening these terminals, by opening this A and B terminals, effective resistance we need to calculate. Effective resistance is nothing but how much? 15 ohms So now for this, what you need to do, whatever voltage source is there, that voltage source we have to short. Means like if you do 10 ohm, 10 ohm, 15 ohm, this voltage source, whatever voltage source, that voltage should be shorted like this. Like this you need to calculate Rn. Okay, here 10 ohms is there, here 10 ohms, here 15 ohms. Now this is current source is shorted, sorry, voltage source is shorted with internal resistance. Internal resistance is how much given? 0 ohms is given, so 0 ohms short. So now this 10 ohms, this 10 ohms in parallel, so 10 ohms, 10 ohms, if two resistors are in parallel with uh, same value, then what is the value? 10 by 2, 5 ohms. Now this is 5 ohm, this 5 ohm is in series with 15 ohm, then total resistance is how much? 20 ohm. 20. This 20 ohm is the Rn. Rn means Norton's resistance. Okay, Norton's resistance. Okay, like this we can do the calculation for Norton's theorem. Okay, clear. Next we'll go to the maximum transfer theorem. What is maximum transfer theorem? So before going to concept of this one, maximum transfer power theorem you can say. So maximum transfer power theorem, this theorem is saying that in any electrical or electronic networks, what is the condition to transfer the power in maximum amplitude? In maximum amplitude means what is the condition to transfer the input power to output in a maximum extent? So that indicates the maximum transfer theorem. Okay, for this condition is, we'll see. Suppose this is generator where internal resistance is Rg and series resistance is R and load resistance RL. So in the network theorem is saying that a resistive load will abstract maximum power from a network when the load resistance is equal to the resistance of network as viewed from the output terminals. Load resistance is equal to the effective resistance of the network, okay, with all energy sources removed, leaving behind their internal resistances. Means whatever, suppose if you open this A and B load terminals and calculate the effective resistance, that effective resistance if equal to load resistance, in this case the total whatever energy, the total power, the maximum power will pass from input to output. So this is called maximum transfer theorem. So you can find out in some by solving some examples you can understand. And what is maximum power at this condition? What is maximum power at this condition is formula is E square by 4 RL or E square by 4 RI. RI means effective resistance of network after opening the load resistances. Okay, because RL and RI is equal, so we can represent E square by 4 RL or E square by 4 RI. This is maximum transfer power equation. So you need to consider in competitive exams, this is a very important question. Under maximum power transfer condition, what is the resistance? Load resistance is equal to the effective resistance of the network. Okay, like what is the maximum power equation? E square, En means here voltage source. Okay, E square or some places V square, V is also nothing but voltage. E square by 4 RL. Okay, this maximum transfer theorem. Okay, clear. Thank you.